Okay, welcome to week 7, day 2 of IS 50A. We just watched some presentations by some of the groups, and it's nice. It's a good job. Very solid job you guys did. And everybody on Discord, please give them the applause emoji for doing that. And I was worried about the test. It was very easy. I know, right? Like linear algebra. Really, arithmetic. It's arithmetic. And so I'll go over the answers here. Half the class didn't do it. It's like, damn, dude, this is a quarter of your grade to take very simple math tests. And okay, so if you have a point at 3, 4 and you translate it right, 2 in the x direction and 2 in the y direction, you get 5, 6. 3 plus 2 is 5, and 4 plus 2 is 6, and that's about all there is to that. Suppose you have a point at 10, 20, and you translate it by 2 minus 2, then that turns into 12, 18. Adding 2 to 10, adding negative 2 to 20. Suppose you have a point at 5, negative 6. You translate it. How far would you need to translate it to get to the origin? You have to translate it 5 left and 6 up. So if you're at 5, negative 6, you have to go 5 right, 6 up. So it's 5 and, 5, negative 6. So you have to go 5 left and 6 up. So negative 5 and 6. Screen share? Oh, no. There you go. It's just the quiz we were looking at last time. Okay, so yeah, it's just addition. In general, the rule for, so we can talk a little bit about vector arithmetic and linear algebra today. Seems like a good time. It's not streaming? It's streaming, isn't it? It's streaming? Yeah, streaming. Okay. Are you guys connected on the stream? 2 people are. Can you guys not connect? It only shows, oh, now there's 4 people. Okay. All right, cool. All right, so let's learn about linear algebra. So, this is 225. All right. So, linear algebra is essential. It's essential for game development, especially 3D games. 2D games, it's pretty important too, but for 3D games, it's really important. And the reason for that is because with 2D games, you typically aren't rotating, things too often. It's kind of weird to rotate in a 2D game. Maybe you do. It's not as common. All right, so linear algebra is actually the very last math class you have to take as a computer science major. So you might think it's the hardest because it's the last one. And you take it after all of your calculus and all of your differential equation stuff. And nope. It's the easiest. It was the easiest college math class I took. I got an A in it, like pretty easily. It's not to brag. It's just, it's not a hard class. And so the thing is, like, if you have a point, it's got an x and a y and a z, right? There's some point. You guys all know graphs and things like that. And so what we were doing with translations is we're essentially adding, this is a vector, which is a vector it just means more than one number. That's all a vector is. A vector is just more than one number. It's a 1D array is another way of putting it. Now, that's all a vector is. And in physics, they'll draw them as like a line, as like an arrow, that kind of thing. It's the same thing. It's just, what does it mean? Velocity doesn't mean position. It's just a matter of interpretation. All it is just 3 numbers together. That's all it is. And so there's some rules. So there's vectors and there's scalars. Scalar sounds like it's scaling something. No. Scalar just means one number. For example, 5. That's a scalar. So you've been using scalars all along and not knowing it. Hey, can you do scalar math? No, that sounds like complicated college math. Really, what's 2 plus 2? 4. All right, you just did scalar math. So, yeah. So you can take a scalar plus a scalar, right? For example, 2 plus 2, you get 4, right? And then you can do a vector plus a vector. So for example, like we did on the quiz, 3, 4, and 2, 2. So there's a couple different ways you can write it, sometimes with curly braces. 3, 4, that's a 4, not a 9. 3, 4 plus 2, 2. And when you do vector addition, you just add the first number of the x part together, and you add the y parts together, right? So 3, 4 plus 2, 2 is 5, 6. Okay, easy. You guys, cool? Vector arithmetic. Okay. Now let's get to something really hard. This is called vector subtraction. All right, so vector minus a vector. So 3, 4 minus 2, 2 is equal to 1, 2. That's a 4. What do you guys think? You didn't know college would be this difficult, huh? 3 minus 2 is 1. 4 minus 2 is 2. The same as addition, but it's subtraction. So, when would we use vector subtraction? That's actually probably better. Like you're like, but professor, this is so easy. What does this have to do with video games? Well, let's find out. So let's say that we have a game. Let's say we're looking down at the world from above. We're looking down at the world, and we've got a guard. The guard's kind of looking in this direction, and the guard is at location 5, 6, and we're here, and we're at location 2, -2, 2 to the right, 2 down. And if we subtracted these two, we're actually creating a vector from us to the guard. So if I take 5, 6, 5, 6, sometimes we draw it with smooth parentheses, sometimes curly braces, it doesn't really matter. And I subtract that out, I get a vector that is 3 to the right and 8 up. So this tells me 1, 2, 3 to the right, and 1, 2, 3, 4, 5, 6, 7, 8 up. So the guard is 3 to the right of me and 8 above me in the y direction. So, do you guys see that? So if I have a position and a position, and you subtract them, then if you subtract the two positions, you get what's called a displacement vector, which is a really complicated way of saying so how far you are away from the other person. Okay. Ada, what is 5 minus 2?
3.
What is 6 minus minus 2?
Hmm?
What is 6 minus minus 2?
2.
6 minus minus 2. So subtracting
Oh,
a minus.
Let's see, that's like -4.
6 minus minus 2 is the same as adding 2 to 6. So 6 minus minus 2 is the same as 6 plus 2, which is 8. Very good. Okay. So third grader can do it. Okay. Yeah. So a displacement vector, we use this all the time, right? Like if you want to know, here's a guard, here's me. Especially, let's say you're writing an AI, maybe, right? Like you're writing a bot. Which way is the guard from me? Well, you take his position, subtract your position, and that gives you a vector pointing in the direction of the guard. And then maybe you do a trace line, and you see if there's an open path between you and the guard. And if so, then you're like, I can see the guard. Cool. Or if there's a wall there, you're like, all right, I know what direction the guard's in, but there's a wall there, so I'm going to pretend I don't know where he is. And that's very, very common in video games, right? You will subtract two positions to get a displacement vector. What if you want your AI to just rotate to look at the person, right? Then what you do is you, like let's say the AI is facing that way. You subtract the two positions, you get this, and then you normalize it. So before we talk about that, how far away is this guard? So if the guard is 3 to the right and 8 up, we're just in a 2D world for now. If the guard is 3 to the right and 8 up, how far away in units is the guard from the player? Or from the AI, let's say. So the first thing we might do is just say if they're too far away, just pretend we don't see them. Right? I've been playing a lot of Valheim with my daughter, and so like if you're this far, like if there's a deer on the far off hill, it just doesn't see you. Right? So that the AI knows where you are. And what it's going to do, it's going to do a displacement vector from the deer to you. And then if there's an obstructed line of sight, it won't see you. And if you're too far away, it won't see you. Do you guys remember how to do the Pythagorean Theorem from Algebra to compute distances? Okay. So the answer here is if you have x1 and x2, this is x1, x2, you subtract their values and add them to y1, y2, y1 minus y2, square that, take the square root of the whole thing, and so I've already actually subtracted them, so it's just going to be 9 plus 64 square rooted, which is 73, it's going to be 8 point something, 8.5, okay. So the AI is 8.5 units away from the guard. Okay. So we got the guard here, we got the AI, that's an I swear. And we have the AI down here. And so if the AI says only see people within 50 units, then okay, cool, we're good. But if the guard was more than 50 units away, then the AI would just like carry out its business, blissfully unaware of the player or guard or whatever further away. And so we use these displacement vectors all the time. For example, the length of the displacement vector. So if you want to know what the length of this is the equation right here. This is the equation for the length, that's terrible handwriting. Length of a vector is that. Okay. So you just Pythagorean theorem. Okay. Yep. So position 1, position 2, subtract them, and then you just square the x, square the y, add them together, square root the result. If you've done algebra, you probably remember the Pythagorean theorem. It comes up. It's useful. So that is, if you want to know how far away somebody is from somebody else, you use the Pythagorean theorem too. All right. You guys, let's do an example. Let's just see if you guys can do this. Okay, so we've got a guard at 1, 2, 3, 1, 2, 3. So we got a guard at 3, 3. And then the player is going to be at 6, 8. So the player is here, the guard is here. How far away is the player from the guard? So take a moment, I'm going to pause the recording, and you're going to use the Pythagorean theorem. So it's Remember, it's x1 minus x2 squared plus y1 minus y2 squared. Can't scroll up. That's unfortunate. And then the whole thing square rooted. x1, x2. It doesn't matter which one is x1, which one is x2, y2, y1. It really doesn't matter. Just call it 1 and 2 for the hell of it. Okay. You do a graph. That's cool. That's neat. All right. So let me pause the recording and let you guys figure that out. Okay, so to compute the distance between these two, the distance is going to be the square root of 6 minus 3 is 3, and 8 minus 3 is 5, squared is 25. 9 plus 25 is 34, so the answer is the square root of 34. All right, so which, according to the calculator, is 34 square rooted is 5.83. Okay. Okay, so that is how you compute distances between things. Right. The way you compute a distance is you subtract the x parts, you subtract the y parts, square them, add the squares together, square root them. It's Pythagorean Theorem. So if you've taken Algebra 1, you should be okay with that. So that's how you compute the length of a vector. Now, let's talk about normalizing a vector. So you guys all know how to add numbers together, I hope. Ada, what's 2 plus 2?
4.
Good. All right, so that's just normal addition. If you add 2 vectors together, you just add the components together, right? So just get my handwriting a little bit there. Dang it. It's very sensitive. There we go. 3, 4 plus 2, 2 is 5, 6. Vector minus vector gives you what's called a displacement vector. This is actually very useful. That's how you get a vector pointing towards something. And depending on which one is first is the person that's being pointed towards. So if you have the guard minus your position, it gives you a vector pointed towards the guard. If you do your position minus the guard's position, it's a vector pointing from the guard to you. It's a direction vector. It's not a position, it's a direction. If you subtract 2 positions, you get a direction. Yeah. Okay. And then if you take the length of a vector, you take the length of a vector by, come on, come on, come on, come on. No. OneNote is so terrible. It does this thing where you like can't click on the buttons. So to compute the length of a vector, it just keeps reselecting this again. All right, quit out of OneNote. It does this all the bloody time. So the length of the vector is equal to the square root of one endpoint minus the other endpoint's x parts added to y1 minus y2 squared. So if you have a vector and the vector is like x1, y1, comma, x2, y2. So it's got 2 points. That's a point, that's a point. The distance between them is computed with that. Okay. Oh my gosh. You're kidding me. You're kidding me. Why are you doing this? My pen is nowhere near. Select. There we go. Nope, it unselected. Really? You're doing this? You're doing this? Really? So if it's maxed, no? No. Alright, I'll quit out of it again. Okay. There we go. Alright, it's working again. Okay, so that's the length of the vector. Now let's talk about normalizing a vector. Again, this word normalize sounds super technical and complicated and stuff like that, right? The conceptually, it's very easy, right? To normalize a vector means to make it length 1. Okay, so if we have our if we have a displacement vector pointing from the guard to the player, that will tell you how far away the guard is. But a lot of times we just want to have a normal vector, a normalized vector, pointing at the guard or whatever. And that's what I'm saying. Like if the AI is currently looking this way, and it wants to look at the guard, like it wants to rotate to look at the guard, you need to have a vector pointing in the direction that is the direction you want to look. You're going to do this on Unreal Engine. You're going to rotate towards a vector, right? You're going to have a blueprint kind of thing, and the blueprint you feed it a vector. That's the direction you should turn towards, and then you'll see the AI start rotating, and looking at the guard. And so, in order to do that, you need a normalized vector pointing in the direction of the guard. And so, a normalized vector. So if you have like in this case, we have a vector pointing this way. A normalized vector is just a vector of length 1, pointing in the same direction. Okay. So if we have this one is like 3, 8 or whatever, then this thing is a length of 9 plus 64 or whatever. We figured that out to be 8.5, I think. So this has a length of 8.5. This one has a length of 1. And so in order to normalize the vector, almost landed. If you want to normalize the vector, you take this vector here, you divide it by its length. You divide it by 8.5. So how do you do that? How do we do multiplication with a vector? Well, it's pretty easy. So to normalize the vector means to make it of length 1. And so in order to do that, though, we need to know how to do vector times scalar math. So far, and it's back on Rainbow again. Fantastic. So we know how to add 2 vectors. We know how to add two vectors. We know how to subtract 2 vectors. We know how to add 2 scalars. Now we're going to learn vector times scalar. Okay. And so if you have 3, 4, and you multiply it by 2, you get 6, 8. What do you guys think? Do you see the rule here? For multiplying a vector and a scalar together? Can you guess how the process works? Same for division. So a vector divided by a scalar. So if you have 10, 6, you divide it by 2, you end up getting 5, 1. This is like the hardest thing here is just math sounds harder than it actually is. So in order to divide 10, 6 by 2, You divide 10 by 2, you get 5. You divide 6 by 2, you get 3. And if you want to multiply 3 4 times 2, the 3 times 2 equals 6. The 4 times 2 is 8. You take each component of the vector, multiply it by the scalar, and put that into the resulting vector. Dahlin bailed out. Shouldn't it be 5 3? Yes, it should be. I did that just to make sure you guys were paying attention. Very good. Excellent job. Good. Good. I want to make sure you guys had your coffee today. There we go. Yes. 10 divided by 2 is 5. 6 divided by 2 is 3. That's all it takes to do vector multiplication or vector division. So how do we normalize a vector? It's very simple. All of this stuff is very simple. Like I said, linear algebra is the very last math class that you typically take in 2 years of college calculus and differential equations and stuff like that. Only 8 people in this class? No, there's 16 people in the class. Only half of them are coming to class. There's a difference. 16 divided by 2 is 8. So to normalize a vector, right? I don't know if it sounds a lot scarier than it kind of is. To normalize the vector, let's say you've got a vector of that's 3 4. You know, it goes from here to 3 4. The length of a 3 4 vector is 5, right? Because the square root of 9 plus 16 is the square root of 25. Square root of 25 is 5. So if you have a vector from 0 0 to 3 4, it's length 5. We write length of a vector, by the way, by using vertical bars. That means length. So the length of a vector from 0 0 to 3 4 is 5. So in order to normalize this vector, you divide it by the length. So if you have a length 5 vector, like that person here, if you divide it by its length, then you're going to get 3 divided by 5 and 4 divided by 5. And that is a unit vector. That is a vector of length 1. So if you have a vector of length 5 and you divide it by 5, you get a vector of length 1. That's how it works. So if you had a TV screen that was 30 inches by 40 inches, it would have a diagonal measure of 50 inches. Would it? 30 times 30 is 900. 40 times 40 is 1600. 2500 square rooted is 50. Yep. And so that's when they talk about like a 42-inch television, they're talking about the diagonal on it. The diagonal of the screen, because it sounds bigger that way. Make that 3 look a little bit better there. Okay, so again, I'm going to give you guys a problem, and I'd like for you guys to sit there with a pen and paper and work through it, and I will pause the recording stream, and then, because I want to give you guys plenty of time to work on it. Last time I think I rushed a few of you guys on it. But I want to see everybody on Discord right now post what they think the answer is. And so I'm going to give you guys a vector. Just to make it easy, it's going to be at the origin on one side, and then it's going to be 8, -2 on the other side. So I'd like for you guys to normalize this vector, which means I want you to come up with a unit vector. It should be pointing in the same direction of length 1, right? I want you to come up with a vector of length 1 pointing in the same direction as 8, -2. Okay, so I'm going to pause the stream now. I'm going to go get some coffee. When I come back, don't type anything on Discord. Just get it ready. But then don't hit anything on Discord, because a lot of people stopped working once other people posted something on Discord. So just type it in, but don't hit return. And then when I come back, we're gonna all hit return at the same time and see if you got it. Okay. All right, I'm back. Everybody please hit return on your Discord chat channel. So Stafford divided both of these by 2. That -4, 2 is not a unit vector, right? Because it's of length greater than 1. You can always double check your work by just taking the length of whatever vector you get. So 4 squared is 16 plus 2 squared is 4. Square root of 20. So you made a vector of length 4.4. So that can't be a unit vector. Unit vector has length 1. Span created 8.24, 8.24, which is also going to have, I should probably just keep the calculator up. 8.24 squared is that times 2. So that's a vector of length 11. So that is also not correct. Vaclar's parentheses don't line up, so I don't know. So let me run you guys through this, okay, rather than torturing you guys. So the length of this vector here is the square root of 8 squared plus 4 squared, or just 4. Yeah. So 64 plus 4 is 68. 64 plus 4 is 68. And do I dare try the eraser? Yeah, so square root of 68 is 8.24, so that's where the 8.24 came from. Okay. So what you need to do is divide by the length. So the length of the vector 8, comma -2, the length of that is 8.2. And so you need to do a vector divided by scalar. Okay. So you take a vector, you divide it by the length of the vector. So we're going to divide by 8.2. So our vector is going to be 8 divided by 8.2, comma, -2 divided by 8.2. That's the answer. If we simplify this down, we will get 8 divided by 8.2 is 0.97. So it's 0.97, comma, 2 divided by 8.2, -0.24. So whenever you normalize a vector, both components are going to be between 0 and 1 or 0 and -1, right? If you ever get an answer that's not between 0 and 1 or 0 and -1, your answer is wrong because it will have a length greater than 1. Okay. So yeah, it's fine. That's why we're doing it in class here, so you can get practice doing it before it's on a quiz, right? All right, let's do one more. All right, so. So let's normalize. Is the eraser still on? It's doing it again. It's doing it again. Microsoft. Why are you doing this to me? There we go. All right. -6, -8. Yep, normalize that vector. I'll go ahead and pause the screen. Step 1, take the length of it. Step 2, divide by the length. So step 1, normalize the vectors. You figure out the length of this. So use the Pythagorean Theorem. So be 6 squared plus 8 squared, square rooted. And then step 2 is you're going to divide by the length. All right, so I'll pause it again and let you guys work that out. Yeah, so normalized vectors or normal vectors are used in a lot of circumstances. There's a lot of things in computer graphics and video games and things like that that require you to have some vector where the length of that vector, we use absolute value symbols, is 1. A lot of things require you to have a normalized vector. And in fact, in Unreal Engine, there is a node that you can feed a vector into it called normalize, and it'll normalize it for you. But you have to understand up here what's going on before you can kind of use it. So you have to understand the theory of this stuff before you use it. It's pretty straightforward. So the length of this is the square root of 6 squared plus 8 squared So that's 36 plus 64, which is 100. Square root of 100 is 10, right? And so that's step 1, take the length. The length is 10. Okay. Step 2, divide by the length. So a vector divided by a scalar creates another vector where each component is divided by 10. And so this is going to give us negative 6/10 and negative 8/10 as the answer, which you can also write as 3/5 and 4/5, or as negative 0.6 and negative 4/5, or you can write it as negative 0.6 or negative 0.8. Either way, there's a lot of different ways you can write these things, but that's basically the answer. So negative 0.6, negative 0.8. And you can verify that the answer is correct by computing the length of that. So if you're like, isn't that bigger than 1? Yeah, it should be bigger than 1, right? It's 0.8 and 0.6. And so you can just go 0.6 squared, it's 0.36, 0.8 squared, 0.8 squared plus 0.36, and you get 1 as the answer. So if you ever want to check to see if your normalized vectors are correct, you do the Pythagorean distance on them, and Pythagorean Theorem, same thing, and see if the answer you get has a length of 1. Okay. Can we try one more? Absolutely. Absolutely. Let's do one more. We got, well, technically it's 4 o'clock, but who cares? Math is fundamental. Okay, so, okay. So negative 5, negative 10. The other one I think I drew in the wrong quadrant, whatever. Negative 5, negative 10, normalize. So it's a vector pointing down here. I drew it at whatever, it's more like, whatever, it doesn't matter. It's a vector pointing that way, kind of. Not exactly. Wrong slope, who cares? So normalize this vector. I'll pause it one more time. All right, so step 1 is compute the length of negative 5, negative 10. And so negative 5, negative 10. Again, I'm making it easy on you guys because one end is at the origin, which makes computing the length easier. If you didn't, you'd have to subtract the two ends from each other. So it's going to be 25 plus 100 is 125 square rooted. So this has a Pythagorean distance of 11.18. So our answer is going to be negative 5 divided by 11.18 and comma negative 10 divided by 11.18, which is going to be memory plus 5 divided by memory recall is 0.48, negative 0.48 of course. And then the other one is 10 divided by memory recall is 0.89, also negative. So the answer is negative 0.48, negative 0.89. Okay. Okay. So Habron, well done. Vacalar, good. You can round it to different numbers if you'd like, but you just learned what the MR button is? Yeah. Yeah. So when you're using a calculator, you can memory clear to clear the memory. You can hit memory plus to save the current number into the memory, and memory recall to recall it later. So yeah, really useful when you're dividing a bunch of numbers by the same number. Just save it and then, yeah, super useful. You don't have to. You're not going to get rounding errors also that way, because a lot of people will just be like, all right, it's 11.18, but yeah, you're losing all those extra digits of precision. So that is our class for today. The class for today is entirely math, but all of these things are really the foundational building blocks of video games, which it doesn't look like it. Like, it looks like just math, like addition and subtraction and length and multiplying, but man, these are used everywhere. Anytime you have a gun and you want to see if something's within range, You take the length from the point of the tip of your gun to the point that you're shooting at. If it's beyond the maximum distance, you play a sound, but it doesn't hit anything. You know, like, these are just what makes up 3D video games. You just have to know it. Otherwise, you're just kind of flailing around in the dark. Like, how do I, you're just Googling things left and right, like, for really basic stuff that you shouldn't need to Google. You should Google things all the time, but you should be Googling advanced stuff, not basic stuff. Like, how do I get my AI to look at the player, right? Subtract the two positions, normalize the result. That's the direction the AI should look at. And then there's a function called rotate towards vector, and it'll start rotating. You give it a rotational speed and it'll rotate towards it. Easy peasy. Really hard if you don't know the theory. Really hard if you don't know linear algebra. You're going to be finding people's blueprints online and staring at it and not knowing why it's rotating in exactly the opposite direction. Well, it's because you subtracted the wrong thing from the wrong thing, But with these tools under your belt, you can basically code interesting things in video games. And we're not quite done yet. There's, really one more lecture on this. But this is the really important stuff today. This is the most important math you need to know. Okay. All math has roots of addition, subtraction, multiplication, division. Yep. Yeah. So if like I could teach my daughter how to do all of this stuff. None of this requires differential equations. None of it requires calculus. Trig, I guess it's kind of related to trig, is the Pythagorean whatever. But when we get into dot product and cross product, maybe next time, there's maybe a little bit of trig in it, but you still don't need trig to do it. So yeah, really just 7th grade, 8th grade algebra. That's all you need to do this. Okay, so hopefully you guys won't drop out. Hopefully this didn't scare you guys off from video games, because you have to know a little bit of math. You have to know how to add and subtract and multiply and stuff like that. Last semester, this was the time when there's a big drop off in the class. And it's kind of, I don't know, like 3, 4 times 2 is 6, 8. Like, to me, that's pretty, I don't know. That's not scary. I don't know. But it's just me. Who knows? Maybe I'm a genius and I know how to add 2 numbers together. I don't know. Who knows? So that's it for today, guys. Thank you. Your homework will be just doing a quiz. There's going to be a quiz on this. It'll be up on Canvas probably in a few minutes. And you have until the start of next class to do it. So half the class didn't take the last one, and it was literally just adding 2 numbers together. So I don't know what to tell you. Like, maybe we're approaching the cliff of doom again, where like half the class just starts coming because they don't want to add numbers together. So who knows? Who knows? Might have to rebalance the groups or something like that afterwards. Like, if people are just going AFK for some reason. I don't know. So, if you have any questions, ask me. Don't drop out. Don't go AFK. Don't stop doing work. Just ask me, and I'll explain it to you. I have office hours every day, and I answer Discord 24/7 mostly. Okay. All right, that's it for today, guys. Thank you very much for coming, and I will see you next time.